The ocean, often called the global conveyor belt, is in constant motion due to thermohaline currents in the deep ocean, as well as wind-driven currents in circulation cells on the surface. Thermohaline circulation depends on changes in density and, inadvertently, on salinity and temperature. Environmental factors which lead to an increase in ocean salinity include rivers carrying dissolved solids flowing into oceans, volcanoes emitting gases to the atmosphere which then equilibrate with the ocean, the freezing of sea ice, and the evaporation of seawater. Factors which lead to a decrease in ocean salinity include sources of fresh water, such as rivers, melting ice caps, and precipitation, as well as precipitation of salts and solids, and the subduction of the seafloor. Salinity varies with latitude due to variations in precipitation and evaporation. Salinity is also at its highest between 20 to 30 degrees latitude, near the tropics of Cancer and Capricorn, and higher at the equator than at the poles, because evaporation rate is much higher at the equator. Global circulation is not just affected by differences in surface density, but also by the differences in deep water density. The thermocline represents the region of the ocean in which the temperature changes dramatically. The halocline is where salinity varies drastically. Surface waters in the tropics are the saltiest. Pycnocline is the region where density varies drastically. These variations in surface and deep ocean water density drive global circulation. The Gulf Stream, for example, is a warm ocean current originating in the Gulf of Mexico and traveling north, bringing heat from the equator to the poles. Warm water has a lower density than cold water and rises to the surface. As the water flows north, it becomes colder, releasing heat into the atmosphere, and saltier due to evaporation, and as a result becomes very dense. This water then sinks. The Gulf Stream effectively transports heat, salt, and nutrients, and is driven by the sinking of the North Atlantic deep water. When northern deep water sinks, it allows the warmer water from the Gulf Stream to take its place at the surface. Cool deep water travels south, taking nutrients and oxygen along with it. In this way, the thermohaline gradient drives the global conveyor belt.